All right, so now let's talk about our solutions here and our solubility, right? Our solubility is is a measure of how much solute, right, the small part, will dissolve in a certain amount of solvent, the large part, at a given temperature, okay? So if we say something is soluble, right, it will mix, right? It will dissolve, okay? Will mix or will dissolve. Okay? When we talk about two liquids, that's when we talk about something that's miscible, right? But if we have a solid or a gas mixed into a liquid, right, that's when we're going to talk about our solubility. And we're going to say, will something, right, is something soluble or insoluble? Insoluble is just the opposite, right? It will not mix. Okay? And so when we decide if something is insoluble or soluble, really what we're doing is we're measuring the concentration, right? So the concentration is a measure of the amount of solute per amount of solvent, okay? We are going to be measuring that, right? That's what our concentration is, okay? So when we talk about those concentrations, right, we either talk about dilute or concentrated solutions, okay? So a dilute solution has a relatively small amount of solute dissolved into a relatively large amount of solvent. Okay, so this is when we would say, we would call it a dilute solution. Okay, if we use it as a verb, right, when we dilute something, right, to add, what did I say? Or add or increase the solvent amount of a solution, okay? So if we have a dilute solution, we would have small amount of solute, large amount of solvent. Maybe we are diluting it further, and that means that we're making this solvent even larger, right? We're going to be adding even more water, okay? Something like that, okay? So our concentrated solutions, right? Concentrated solutions, solution that has a relatively large amount of solute dissolved into a relatively small amount of solvent. Okay, so this would be our concentrated solution. Whoops, didn't give myself enough room there. Right, a concentrated solution, right, we've got lots of solute dissolved in that solvent. Okay, all right, so how do we actually measure these? Well, we're going to skip over this page. We'll come back to it. We have solubility rules, okay? So these solubility rules, right, tells you whether a substance is soluble or insoluble, okay? So it's used to predict whether or not a precipitate will form when two ionic solutions are mixed and undergo a double replacement reaction, okay? So if we remember a double replacement reaction, right, that's going to be, let's do AY plus BX goes to AX plus BY, right? We have two compounds. Those two compounds swap places. And we're going to be able to decide if we're going to make a precipitate, right, when we look over at these two compounds, okay? So a precipitate, right, this is a solid product that falls to the bottom of a mixture or solution, okay? So if we go from two clear solutions, right, two clear solutions, and then all of a sudden we get something that's opaque, that would be us forming a precipitate, forming that solid, okay? So a precipitation reaction, right, would be a double replacement reaction where we go from two clear solutions to an opaque solution, right? That's when we are forming a precipitate, okay? So it is going to be visible, right? We'll generally be able to see it, and we will see one of those solids kind of forming at the bottom. So how do we decide? Well, we get to use this table, okay? So take a look at this table. If we look on here, we have two compounds that are, or two rows, sorry, two columns that are listing a whole bunch of our ions, okay? We have group 1 ions, but then we also have our polyatomic ions in here, right? We've got a whole bunch of polyatomics. So we need to know our polyatomics, right? But if we have a compound that is hopefully going to form, right? It's going to form AX, okay? If it is going to form AX, maybe it has ammonium as that A. Well, ammonium, if we read at the top, is going to form a soluble compound in water, okay? Ammonium is going to be soluble, and we don't have any exceptions to it. So ammonium is always going to be soluble, okay? If we also, maybe let's look at another one, right? We can look at column 1 here. We could think of, let's go look down at the bottom. Let's look at some practice. KNO3, right? KNO3, we could look at potassium. Potassium, right? That would be a group 1 ion. So that is going to be right up here. Or we could look at nitrate. Nitrate, right, is going to be soluble as well. We don't have any exceptions there. So this would be a soluble compound, okay? Let's try and look at calcium carbonate here now, right? Calcium carbonate, we don't see calcium listed anywhere here in group or in column 1 or column 3. So let's look for carbonate. Carbonate is CO3 2-. We go look this column, it's not showing up, but over here in column 3, it is showing up. Column 3, it shows up as insoluble, but then it has some exceptions. So carbonate, it is combined with calcium. That is not a group 1, and it is not ammonium. So therefore, it is still in this section right here, which means that it is an insoluble compound. Okay, so that is how we can use this table to understand what is soluble or insoluble, okay? This table up here, right, would be something that I would give us. You just need to know how to use it, okay? Okay, so what we're going to do is we're going to start seeing some of these reactions, and we're going to be able to start identifying those solutions as those reactions as a precipitation reaction or not, okay? We want to identify those precipitation reactions. So we're going to do this in the lab. Those of us online, I think we have another video for you, okay? All right.